so what we're going to do is we're going to extend many of the things we have just done, but into 3 dimensions. The first thing we need to know is how things operate in 3 dimensions. It's a lot of fun. So the point is, in this space, I've labeled a few things. The YZ plane is the whole wall right in front of you. The XY plane is down below, and the XZ plane labeled over there underneath the cranes is the XZ plane. If you go to the corner of the room right there, the bottom left corner, the vertical crease, the vertical corner of the wall, right, that'll be the Z-axis right there. That'll be the Z-axis. And then coming to your right is the Y-axis, and coming straight at you usually is what the perspective is, the X-axis. It seems a little strange and arbitrary, but here's the point. It just is. That's how it is. Don't go rechanging them. Z is up, Y is to the right, and X is coming straight at you. Yes? Correct. So what are you looking at? You're going to draw this a whole bunch. Z goes up, Y goes to the right, and X comes at you. This is called the first octant. The first octant. So you think to yourself, okay, it's like quadrant. First quadrant, second quadrant, third quadrant, fourth quadrant. How many octants are there going to be? Ooh, surprise. 8. Is there a set naming convention for them? No, there is not. But the first octant is very commonly the octant where X, Y, and Z are all positive. That's it. When you draw this, I highly recommend, here's the thing. You see how I almost drew it at 45 degree angle right there? You're going to want to avoid drawing it exactly at a 45 degree angle, because what little perspective you're going to be able to master will get totally destroyed if you use 45 degree angles. There's probably a good artistic way of saying that, but when you're drawing these sets, like this first octant, don't use 45 degree angles. Just don't do it. R cross R is the set of all ordered triples of real numbers, and it is denoted R to the third, R3, 3-dimensional rectangular coordinate system. So that set, X cross Y cross Z, where all of them are real numbers, will denote every single point in 3 space. Yes? 3 space, just one of them. That's 3 different things. What does X equal 4 look like? Well, you draw it's a plane, exactly, right. So you have Z, Y, and X. X equals 4 is just the set of all points where X equals 4. So if X equals 4 right there, what are you looking at? You're looking at the plane right here that crosses right there. Crosses right there. It's the plane. Doesn't matter what Z and Y are. Doesn't matter what Z and Y are, but X is 4. So each of those are planes. Yay. Planes. This is going to represent, what does this mean? Anybody want to guess? What does this mean? Distance. Yeah.
What's the thing with the double?
From D to A. The double. The double, it usually can mean magnitude or just distance. There are redundant notations. Different things mean the same thing. So the distance formula in 3 dimensions, what is that? If you wanted to characterize what that is, careful. If you want to characterize what that means, what is this? This is the distance from point 1 to point 2, but how would you characterize that formula? What is it based off of? Yeah, it's just a 3-dimensional Pythagorean theorem. Can you draw a 3-dimensional picture of this and do it out? Absolutely. There's a picture of it in your book. I'm not going to spend time doing it. It's not that long. You get one side in terms of 2 of the box, and then that's just, you can get it. So that is the distance from point 1 to point 2 right there. Okay, of the circle. So in this case, we could have a sphere. It's going to be x minus h squared plus y minus k squared plus z minus l squared equals r squared, where hkl is the center. And what's the radius of this sphere? R. The radius is r. So, for example, it's not always written nicely. I could give you this and say, what is that? And you'll know I'm telling you, what is it? It's going to be a sphere. In order to show or tell me more about what that sphere is, like the radius in the center, which is really what you need, because that uniquely defines a sphere, you're going to need to rewrite it in the proper form. So what are you going to have to do 3 times? Tells you right there. Yeah, right. You're going to have to complete the square 3 times. So you end up with x squared plus 4x plus y squared minus 6y plus, what is it, z squared 2z equals negative 6, right? So what are you going to have to add in each case? Plus 4, plus 9, and plus 1. So what do you have to add to the other side?
The first one should be... Yeah, no, it's correct.
It's correct. And what should I add to both? So if I added 10 to the left, if I added 14 to the left, what do I have to add to the right?
14.
So I'm completing the squares. So this is x plus 2 squared plus y minus 3 squared plus z minus 1 squared is equal to what? 8 is equal to 8. So what's the center of this thing? What is the center of this sphere? Negative 2, 3, 1. And what's the radius? 2 root 2. So you just completed the square 3 times in 1, found the center, found the radius. You've uniquely defined that sphere. You okay with that? Okay. The vector used to indicate a quantity that was magnitude and direction. How would you describe the magnitude of a vector? It's what? Size, length, and direction is it's telling it where you're pointing it, right? So 2, 2, 2 is the same direction as 3, 3, 3, but are they the same magnitude? Do they have the same magnitude? No. It's like a car. 2 cars can be driving on the same road at different times, going in the same direction, and one can be going much faster than the other. So their velocity vectors will be going in the same direction, but they will be much different in size. One will be larger than the other. Right. So you'll see 2 things, and one of them is really annoying, and you might have seen this before, but it's just how it is, and I don't know why this was chosen as a good thing to do. The vector v, you'll see it as, I'd imagine you've seen the vector v as something like, not but I would say you've seen this before, like 2, 2, 2 as a vector, right? With that little arrow on the top, little vector thing. You will also see it denoted as v bolded. I don't know. I think they were just like, I don't want to have to do another symbol, so I'm just going to hit Control B on my keyboard after highlighting something. It's really bad because you will be looking at something and you're like, I don't get this. This makes no sense. That algebraic manipulation, and then you realize, wait a minute. They're vectors. Okay? So if you see a bolded letter now, what is it going to mean? Vector. It's annoying. Just deal with it. I can't remember how common it is. I honestly don't remember how common. I know it's used all over this book, so just be careful. V can be denoted A to B, and that's actually an arrow right there. You can't really see it. This is supposed to be that. The initial point is A, and the terminal point is B. If you have 2 vectors and they're the same length in the same direction, they're called equivalent, but their position can be different. Like a vector from A to B has a specific starting point and a specific end point, right? But the vector 2, 2, 2, where could you draw the vector 2, 2, 2 in 3 space? Anywhere you want, right? 2, 2, 2. It doesn't say exactly where it is. A vector, the 0 vector 0 has length 0 in no direction. Vector addition, triangle law, parallelogram law. When you add vectors together, what do you add? If you have 2 vectors and you add them together, what do you add together? The corresponding parts, right? The x values you add together, the y values you add together, and the z values you add together. Right, exactly. So the idea is this. If you have 2 vectors, let's say you had in 2 space, you've seen this before, you had one vector going off like this. Oh, that's going to be really confusing if I did that. Let's say I had this vector. Oh, man. I'm drawing axes again. Let's say I had a vector like this, going from here to here. And then I had another vector just floating out in space, I don't know, like this, going from here to here. If I want to, let's call that vector A, and we'll call this one vector B. If I want to add vector A to vector B, how do I do that? You take you want to add vector A to vector B. You take vector A, and what do you do with it? You tack it on the end here, like that, and then your new A plus B is going to be what? The initial of B all the way to the. So this right here is plus B. Now, it doesn't matter what order you add them in. No, it doesn't, because look, if I took A right here, let me take A. Let me see if I can actually. Oh, good, it worked. I think. If I paste this in, if I added it right here instead, just to switch the oh, sorry, excuse me, sorry, careful. What is that green vector? That's B plus A, right? If we wanted A plus B, I copied the wrong one. If I wanted A plus B, what do I have to duplicate here? Let's take B right here. If I take B, put it right there, you put it right at the end of A, like this, and what do you end up with? This right here is A plus B. Are they the same thing? Yes. Remember, it doesn't matter where the vectors start. They'll be equivalent vectors regardless of where they start if they go in the same direction and they have the same magnitude. Exactly. Do an example, right. So in 3 space, so you're not going to draw what it looks like in 3 space because it's a little hard. Let's say you had 2, negative 3, 4, and you're adding to it 1, 2, 3. That would be 2 plus 1, comma, negative 3 plus 2, comma, 4 plus 3. So that would be 3, negative 1, 7, like that. That means is, let's say I had a vector, I don't know, 1, 2, 3, and I multiplied it by 5. What do you do with the 5? You literally distribute 5, 10, and 15. When you multiply something by a scalar, does it change the direction? No, it changes the magnitude. That's it. What happens if I multiply it by -5? What happens to the direction? What do you mean the other way? Be more specific. Yeah, it would turn into this, this, and this. So instead of going off in that direction, it'll go the exact opposite direction. Yes. So if you want to flip it around, a1 squared plus a2 squared plus a3 squared. So if it's 2, 2, 2, it would be 4 plus 4 plus 4 square root. It would be square root of 12. Yes, that's it. Repeatedly writing. So you might see it gets really, mathematicians like to be pretty efficient in what they write. So instead of having to write 1, 0, 0 every time they want to write 1, 0, 0, they just write I. Same thing for j and same thing for k. So if you see I, that means 1, 0, 0 instead of the square root of -1. Let's mix things. Yeah, I know. But I, j, and k mean the three basis vectors for R3. So for example, let's make up a vector, something not too big. Let's say not j because we used that already. How about the vector q? 1, 9, 3. What is the vector a? Kids, shh. What's the unit vector? If I want the unit vector that is parallel to q, can you give me a unit vector that's parallel to q? Can you give me a unit vector that's parallel to q? It's going to be q over the magnitude of q. So it's going to be 1, 9, 3 over the square root of 1 squared plus. So what is that going to be? 81 plus 1 is 82. 82 plus 9 is 91. So it's going to be 1 over 91 times 193. Right there. Can you distribute it? Oh, square root. Yeah, square root, sorry. Can you distribute that in, that constant? Can you just tell me the simple reason why I didn't multiply in that constant? No, it's not too much. I just didn't want to write it 3 times. This way I can write the square root of 91 once. If I distribute it in, what would happen? I'd have to write it 3 times. Now, why do you know that this vector here has the same direction as this vector here? The only thing that's different is the constant out front. If they are linear combinations of each other, how do you get from here to here? You multiply by 1 over square root of 91. They are therefore parallel, but what's the magnitude of this one? 1. Because what's the magnitude right here? Oh, it's square root of 91. What's the square root of 91 over the square root of 91? 1. So that right there would be the unit vector parallel to q. How many different unit vectors are there? Oh, could I do this? Is that okay? Is that still a unit vector? Is it still parallel? Yeah, it is. It's still going in the same. What? Yeah. It's going. They don't intersect. That's all you need. So let's say I said this. There's a big rock being dragged across the ground right here. The rock is being dragged across the ground, but it's being pulled by somebody by a force vector going like this, over the shoulder like this, okay? So let's say how many newtons is being, come up with a Newton measurement. 4.93. How about just like 10 newtons, okay? Is that okay? So the question, so that is your force vector right there. That's a force vector. So here's the thing. That vector, let's call this, I don't know, 30 degrees right here. This vector, we'll call it, I don't know, the force vector. This force vector is equal to a certain horizontal vector plus a certain vertical vector. And we're limiting ourselves to 2 dimensions here, okay? We're limiting ourselves to 2 dimensions. How do we figure out what the horizontal force vector is and the vertical force vector is? Sine and cosine, exactly, right. So look, you have your horizontal vector goes right there, and you know when you add the vertical vector to it, what do you get? Oh my god, right. So you know that fx plus fy has to, that's what I already said, right? fx plus fy. Okay, so what do you know about sine of 30 degrees? No, now I know it's equal to 1/2, but in this triangle,
Sine of 30 degrees is equal to fy
opposite over hypotenuse, right? So what does fy equal?
Fy equals
10 sine 30 degrees. And so what is fx equal to? 10 cosine 30 degrees. And what is sine of 30 degrees?
1/2.
Is 5.
Are you not going to include units?
We will in a second. I'm in math. I'm not in physics, and I'm the teacher, so I finally get to do what I wanted to do in high school, which is not care about units until the end.
Okay.
Got it? What's cosine of 30 degrees?
Root 3 over 2.
Yeah, exactly. So it's 5 root what?
5 root 3.
5 root 3. Exactly, right. So in this case, what does this tell us? This tells us the force in each direction is, it's 5 going horizontal. 5, what are the units? Newtons going to the right. And what are the newtons going up? Newtons, exactly. Foot-pounds. Stop it. Stop it. For example, let's say I said A was equal to 1, 9, 4, and B was equal to 6, negative 2, negative 1. A dot B, which is not multiplication, is going to be equal to 1 times 6 plus 9 times negative 2 plus 4 times negative 1. So that's going to be 6 minus 18 minus 4, which is going to be what? Negative what? Negative 16. So here's the thing. That is the dot product of those two things. We now know how to calculate the dot product, so let's figure out what it means in certain circumstances. Truly new thing. No, you've seen it before?
Yes.
Okay, we'll try to do something you haven't seen before. If theta is the angle between two vectors, A dot B is the magnitude of A times the magnitude of B times cosine of theta. Sometimes you see it written a little differently. What do you usually see? Cosine theta is equal to A dot B over AB. Have you guys proven this in your other classes? Do you know what you used to prove this? Does anybody remember what you used to prove this? Anybody guess? Anybody know what that kind of looks like? Law of cosines. You use the law of cosines for this. I don't want to do it. It's not super fun. Did you try it out? It's easier to remember. Now, so you have two vectors, A and B, right here, like this. If you want to find the angle between them, you just dot them. You just dot them, and you divide by their magnitudes, and you get the angle between. What's a useful? Can you give me one super useful angle between? This right here being the angle between. I'll call it alpha. What would be a really useful? Or what? 90. Let's go for 90. 90, right? Okay. 90 degrees. What do you mean it's 0? Which is 0? Cosine of 90 is 0, right? Cosine of 90 is 0. What's the only way for a fraction to be 0? The numerator is 0. So what did you just prove? Two vectors are perpendicular if what? A dot B is equal to 0. There's your second thing. Yeah. They don't talk about that in multivariable. You don't need to worry about that yet. So listen, here's the thing. If you believe that this is true, which you do because apparently many of you have seen it and proved it before, you can use it to say that, oh, okay, well, if the angle between them is 90 degrees, cosine of 90 is 0. The only way to get a fraction equal to 0 is have the numerator equal to 0. What is the numerator? A dot B. So what can you use with dot products? Well, if the dot product of two vectors is 0, you know that they are perpendicular. Yeah. What's cosine of 0? 1. So if A dot or skew. Well, hold on. So what happens if you took 2, 2, 2, and you dotted it by negative 2, negative 2, and? What do you end up with? Negative 4 minus 4 minus is negative 12. So you have those vectors are going in the exact opposite direction. What happens if they're going in the same direction? Yeah, we have it right here. We have it right up here. Look, A dot A is equal to the magnitude of A squared.
However, they don't have to be the same magnitude. They just have to be parallel. So you can
Correct.
Have 2, 2, 2, and
try to find that. So you know that cosine of theta is equal to 2, 2, 2. Let's say 2, 2, 2, and 3, 3, 3. 2, 2, and 2 dot 3, 3, and 3 over the magnitude of it. So it's going to be the square root of 12 times the square root of 27, right? Right, that? Well, if you do that out, what happens? What do you get? Plus 6 plus the square root of 12 times the square root of? You get 18. Do we do? Oh, it's just, sorry, multiply. I meant multiplication right there. You have to be careful. You're right. The notation, you have to be very careful about it. I did not mean for that to be a dot product down there. But it's this right here. You can combine them. I'm just writing it out on the top and then messing up down on the bottom without writing it out. So you get the square root of 12 times. What is 12 times 27? I know, this is pushing my... Exactly. Thank you. It's the square root of 324. Ooh, what is that? No, it's 18. So this is 18 over 18, which is? 1.
Which is cosine theta.
Which is, so cosine theta is 1. So what does theta equal?
0.
0. Yeah. Oh, there we go.
Theta equals
That's more
theta.
like an alpha, an omega. No.
That's
theta.
true.
Theta equals.
Theta.
Theta equals
I like
theta.
the way you drew your circle there.
That's not bad. It was stylish. Okay.
It's very funny.
Oh. You?
Hey, I'm doing my best here,
It's like looking
guys.
to AI, so.
Okay. Let's actually just do some of these problems, okay? Let's do a few of them. How about that? You're going to do 2 sets of problems for me. They'll make you feel good about yourself because they're not that hard, okay?
Nothing new.
Do these first, and then we'll get to the truly new stuff. Sound good?
Why don't you just copy and paste the image?
That's why I get text. Okay, guys, books are over there. You can get to work on these.